The National Research Council, which is composed of scientists, addressed this question, and they came up with several principles to help guide what we should be doing to help students learn how to think scientifically. This is the K-12 framework for science education, and the next generation science standards developed from the tenets of the framework for K-12 science education. What we see here are going to be some basic principles that the National Research Council developed as they thought about the question of how do we want students to learn science. One of the first principles is that children are born investigators. When you look at how a child first sees, observes, and tests the world, you see that the way they think of it is very much the way scientists would structure their own thinking. Scientific understanding develops over time. In the research arena, science understanding develops over time because of advances in science. Within the classroom and school setting, understanding develops over time because of students' cognitive development and integration of other subjects, such as math. Therefore, we would expect students' understanding of something like electricity to develop over time as he or she moves from concrete concepts like batteries and circuits to more abstract concepts like electron flow through wires. Science is more than just a body of knowledge. As a scientist, I could read about infection, but in order to answer the question, how does infection affect our muscles? I need to perform research. Likewise, in order for students to understand a concept like force, it is necessary for them not only to read information about force, but also to measure force and perform experiments to answer that question. It is important to connect students' science concepts with their own experiences and interests, and to promote equality in teaching science. And we have done that over the past decade, through examples and activities that are tied to what we think will interest them and what we see as fun and exciting. However, this hasn't been enough. We see that from the statistics of how students perform on national and international tests. And the reason why our students' scores have not improved is because too little attention is paid to how students' understanding of an idea can be built on from grade to grade. We have not adhered to the principle that understanding develops over time, and yet research strongly suggests that a more effective way to approach science and learning and teaching is to teach and develop systematically an understanding of the core ideas of science over a period of years rather than weeks or months. So the next question becomes, what are these core ideas? The National Research Council defined these core ideas as concepts that are central to understanding science. Large, overarching principles that involve all scientific disciplines.